This week we're going to be looking at something I've wanted to talk to you about for quite a while, which is the idea of SignalR. And SignalR is a library, in fact a couple of libraries, one for the server side, one for the client side, produced by Microsoft, that's layered on top of a more fundamental protocol on the web known as WebSockets. And WebSockets addresses a problem that was around in the earliest days of the web, which is the fact that when you're using HTTP, what you have is a request response system. So a browser makes a request to the server does whatever processing is appropriate, and then returns a result. But it's always instigated by the browser, by the client. Traditionally, there's not been any way that if some information comes into the server by some other means, then it can push it out and just wake up the browser and say, here, I've got some new information for you. Now, although lots and lots of websites can work without that, anything that has that sort of interaction, typical example is, say, a chat application where somebody on one browser types in a message and that immediately appears for another user on another browser, that needs this kind of two-way communication. The problem used to be fixed sometimes with what's known as polling, whereby one of the browsers would maybe every 5 seconds, or whatever the time period you want, make a request out to the server and the server would make a response. But the problem with that would be that if there was no information coming, then you'd be making this request every 5 seconds. Have you got anything for me? Have you got anything for me? Have you got anything for me? Nothing coming back. It's a waste of bandwidth. On the other hand, if there is some information, you might miss it, or you might at least delay it by those 5 seconds until you make the next request. So what WebSockets, which have been around in its final version really since 2011, so just over 10 years now, what this does is gives us a full two-way communication that we can have between the server and the browser. Now, most examples that you get of WebSockets or SignalR, if you look on the web, are based on that idea of a chat application, which is a pretty obvious example of these sorts of things. But I wanted to do something a bit different, and so what I've got is an example where we are doing rock, paper, scissors. So I showed you rock, paper, scissors in some earlier videos, specifically when we're looking at the strategy pattern. The slight difference here is that was a situation where you were playing against the computer, whereas here what we want is two human players on different browsers, different sides of the world, able to play rock, paper, scissors through a server, and because that needs to push data, that's done using SignalR. So let's actually cheat this a bit and look at the end product that I'm trying to put together, because I think that'll make it a bit clearer as to what we're trying to achieve. So if you look at what I've got here we've just got a page in Chrome connected to our server, and what I'll also do is bring up a second browser. This time we've got Edge, and I'm going to point it at exactly the same website. So we'll just copy the URL out of there, and we see the same sort of thing. Let's just position these so that we can look at them side by side. And let's put in here the name of one of our players. So we're going to have Barney there. You see it says waiting for another player. And then if in here I have Betty and enter that, then you can see on the Barney side we're playing against Betty. On the Betty side we're playing against Barney. And then we can choose what we're going to go for. So I'll click paper on this side. And you can see it obviously doesn't show Betty what Barney selected. It just says your opponent has chosen, so we're waiting. We'll go for rock on that side, and then it gives us the result. In this case, paper beats rock, so Barney beat Betty, and the score is 1-0. And it would just carry on like that. So that's the end product, just to show you what we're trying to achieve, because there's quite a few steps to build up to this. Now let's look at the code that we're going to put together, and I've already put together quite a bit of this. Basically, I've put together the essential game logic, which is all here in this folder called game logic. So what I've got is we've got the signs, that's the enum for rock, paper and scissors, and setting up the rules as to what beats what and what's the draw. We also have the idea of a player that just has a name and then what they've thrown, as it's called, whether that's rock or paper or scissors, what their current score is. We've then got the idea of the game itself. So that's where most of the logic goes. Don't need to worry too much about that. I'm not going to go through this in detail, but if you've got any questions, do put them in the comments if when you're looking at the code there's any of this you don't follow. But we've also got the game, and then we've got the game group, which is where we pair up the two players. So if we've only got one player, we wait for the second one before we begin the game. And all of that is really logic that could have been implemented in any technology. It doesn't have to be to do with SignalR. So that's why I've pre-written that, because it's just logic, it's not technology. The one thing in here that I have put in, however, that is kind of specific to what we'll need in SignalR is that this game group has a name. And all it is a GUID, so just each game group has got a unique name. But what we'll see when we come to the SignalR technology itself is that we can divide our connections, so the individuals, Betty and Barney, the individuals who've connected, we can divide them into groups. So if this were a chat application, you could have groups representing different chat rooms, but here the group represents the pair of players playing a particular game. So that's our starting point. We've also got a very simple controller that just returns an index page, and then in the index page here we have all of that logic that we're dealing with. So basically the index page has three sections. So we've got that welcome that just says enter your name. Then we've got the next phase where we're waiting for another player to connect. And then finally, we've got this section where we're actually playing, and we've got the three buttons, rock, paper and scissors. And we've got the various fields where we're going to display the score information and that sort of thing. And then finally, we've got some JavaScript. And here you can see we've got the various bits of control. So there we've got the register. So when they click the button to register, that's where we're going to go. We also have the clicks for the clicking rock, clicking paper and clicking scissors, and then various messages we pop up there, and we can display there's been a winner, there's been a draw, and then we can switch through those three phases. Remember where we had the welcome or the waiting or the playing that we had as the three sections here. So only one of those is ever going to display. But at the moment, if we just start that up, we'll see if we drag the browser over that we've got that basic start. But at the moment, nothing is working at all. Although we can press the button, it's not doing anything because we haven't done the work. So let's get that working. And with SignalR, there are two sides to the coin. You've got to write some server code and you've got to write some client code. So let's begin with the server code. And what in SignalR terms we deal with on the server side is what Microsoft term a hub. So hub is the server connection to which you can talk to and receive messages from in SignalR. So let's pop in a folder that we'll call hubs, and then into that folder we're going to have a new class that we'll call game hub. And so there we've got the class, and what we'll do is derive that from a base class called hub, and we will get hold of the namespace for that. So you can see there it is in Microsoft.ASP.NET Core.SignalR. So thing to notice, you don't need a separate NuGet package in here. It's actually part of the basics that you get out of the box when you create the MVC application. So that's our hub. And then what we're going to do in our hub is we're going to give it a private static game manager. So you'll see game manager was one of those classes we've got inside the game logic. So that's what we've got there, and we'll just call that underscore manager and then initialize that just so we can create an object. Then we've got to think about what are the incoming messages we're going to get from the client. And if you just think about the way this game works, there are two things basically that the client can do. They can either register when they enter their name and start the game, or they can choose rock, paper or scissors. So those are the two public methods we need on our hub. So the first one we'll do is the register. So we're going to say public async task, and then we're going to just call that register, and that's going to take the name that the user has entered on the client side. And then here we're going to say var group equals and then underscore manager dot register. So I say all this logic has already been written for us. So there we are registering the name. And if we look at that game manager register, one thing you can see, it does have some thread safety in there, because we could get multiple requests at the same time. But basically, that will either start a group if this is the first user, or complete the group if it's the second user, and it returns that group, so we get back the group. And the reason we need to get back the group is to get hold of that group name, because what we now do is we say await and then groups, which is a property we've got from that hub base class, that is the list of groups we've got associated with this particular hub. And then we say dot add to group async. So what we're doing here is we're going to add the current user, whoever has made this registered request, to the group whose name, as we said, is just a GUID, but a unique name for the group. So we do the add to group async, and then to get the current user, we don't want the current user's name, we actually want their identity. So we use another thing called context, which again is a property from the hub base class, dot connection ID, so that's the unique ID that it's assigned to the user, and then that is going to be associated with this unique name, so group.name, and that is really all we need to do there. So we've registered that and then associated this user with the group that we've got there. And then the other thing we need to do, of course, we don't know at the moment whether this is the first user, in which case the group is incomplete, or the second one, in which case it's complete. So then, having got back that group, we can say if group dot full, and then we're going to decide whether we need to wait for a second player or the game can get going. And so if the group is full, we know that we are ready to go. So we're going to say await, and then clients, again a property from the hub base class, dot groups. So we're now going to select all of the clients in this current group. So group.name. So there should be two of them at this stage, the two who have registered and been put together into this game. And then we are going to send those a message. So we say send async. And then the message I'm going to send them, it's just a string. We're going to call this game started, and we'll see on the client side that we'll have to respond to that. And then we can send as many or as few additional parameters here as we like. We are entirely structuring this for ourselves. So what I've decided is that on a game started, I want to send the two player names. So I'm going to say group.game.player1.name, and then I'll also send along there group.game.player2.name. And so that has notified the client that we're ready to actually start playing the game. On the other hand, if it's not full, so if there's only one player in there, then we do the same sort of thing. So we're going to say await, but in this case we just say clients.caller. So we don't want to send it to the whole group, we just want to send it to the person who called this register, so send it straight back. And then on that one we say send async, and in this case, again, I've pre-planned what these are going to be called, so this one is called waiting for player. And so that will just tell them we're waiting for a second player to connect. So already you can see we've got the idea of an incoming message. So we just have a public method. The parameters are whatever you like. So obviously the browser's got to provide a name, but as many or as few, whatever type you like. And then we can see the idea of configuring a group. So putting these clients into groups and then sending messages back. Either we can send a message to all the members of a particular group, or we can send it back to the caller, and there's various other ones as well we can do for that. But that's basically our register. So that was the first of the operations that the browser can perform, that the messages it can send to us. The second one, remember, was when the user actually selects rock or paper or scissors. So that other one we put in is going to be, again, public async task. So these are always async. And then this one we're going to call throw, so that's just the term we use for when they select rock or paper or scissors. And what we're going to have there is a string which is going to be the group name, so that group name that we've just been talking about, and then the player who's made the throw, and then also what their throw was, so string selection. So that's whether it's rock or paper or scissors. So we're saying which game is this a part of, which player within the game, what is the actual move they've made. And then what we're going to do, we need to get hold of the game. So we say var game equals, again, underscore manager, and then we do a dot throw and pass in all of that information. So we're going to do group name and we're going to do player. And then we have a slight problem with the selection that you can see the selection is coming in as a string, but we want it as the enum sign. So we're just going to do an enum dot parse and parse it to this sign type. And then we're going to take the selection and then also, just to make things a bit more helpful, we're going to ignore the case on that. And so that's what we've got there. What this does, what that throw does, is it looks up the game from this dictionary of games based on the group name. It makes the move, and then it just returns the game, because what we now need to do in here is start dealing with the status of the game. So at this point, it could be that both players have made their move, in which case the game's complete, or it could be that only one player has, say, gone scissors, and we're waiting for the other one. So what we now do is we say if game dot pending, so that tells us if we're still waiting for the second player to make their move, and if that's the case, then we're going to do an await. We're going to do a clients dot group. So we're going to send a message out to everybody in this particular game group, and obviously that's with group name in there. And then we do the send async, and this one we're going to just call pending, and then we're going to send out the name of the player that we're waiting for. So we can see that game has this waiting for, so if player 1's played, that will return the name of player 2 and vice versa. And then if it's not pending, so if the game's complete, either a win or a draw, then it's a bit more complicated. So what we're going to do is we're going to get hold of the winner. So that's going to be game dot winner that we can see we've got there. We're going to get hold of the explanation. So the thing about that winner is, notice it's a nullable string. So it'll either give us back a winner, or if it's a draw, it's going to give us back null. And then we've got this explanation, and that is going to be game.explanation. And what that is, if we just take a quick peek, is basically it tells us rock beats scissors, or paper beats stone, or it's a draw, or whatever it may be, something like that. So that's the explanation. Then we say game.reset, and what that does is it increments the score appropriately, so either player 1 or player 2, or neither of them in the case of draw, and then just resets their throws, so it's no longer remembering the rock or the paper. It sets that back to null, ready for the next game. So we do that reset. Then we've now just got to decide whether it was a win or a draw. So if we say if winner equals null, which means it's a draw, there is no winner, then we're going to have, and we can do a bit of copying for that, so we're going to send a message out to the group, so both players in the game, and the message in this case is drawn, and then we're also going to send the explanation, and we're also going to send the overall scores so they can see how they're doing. On the other hand, if we have got a winner, then again we can steal a load of that, but in this case we say 1 and we pass through the name of the winner, again the explanation, so what beat what, and again the game scores. Okay, and really that's it for the logic of our Game Hub. So the actual game logic we saw we'd already written, we don't worry about that, but that's what we've got. We've just got the two possible incoming messages, so the register and the throw, and then we've got these various outgoing messages: game started, waiting for player, pending, drawn, and won. So when we write our client code in the browser, we're going to have to deal with all of those. Only a little bit more to do now on the server, and that's essentially just a bit of registration. So what we need to do is go into our program where we're doing the startup, and then we've got to do a builder.services. And then add Signal R. So that just registers that we're going to use Signal R. And then down here, we're going to say app dot, and then we have a map hub. So that hub is the hub we're talking about in terms of the game hub. And that's a generic. So there we put in game hub. And just get hold of the namespace for that. And then we register that with the endpoint that's going to be used from the browser. So we're just saying there /GameHub. And that's very commonly what you have. It'll be exactly the same name as the class, but they don't have to be associated. You could have all sorts of other things you want. And so that really should be, that'll work. And you give that a quick test build. Seems happy, so that's okay. So that's the server side. Now we've got to deal with the client side. And the client side needs to have, obviously, a JavaScript library to help it to understand SignalR. Now, I mentioned SignalR is a layer on top of WebSockets. There are lots of JavaScript libraries out there that put a layer on top of WebSockets so that you can use them in various environments. We're going to use this week the SignalR one, just to keep it simple, to keep it all consistent. But as you can imagine, there's no requirement at all that whoever's writing your server is the same person who's writing your client. They may want to use entirely different technologies. So in the next video, we'll look at an alternative client-side implementation. But for now, we're going to go just with the Microsoft one. So what we can do for this, if we go to www.root, and then all sorts of ways we can get a hold of a client-side library. We could use a content delivery network, but I'm just going to do add and then go for client-side library. And then we'll go for this UMPKG as our provider, and then lots of choice to go for, but I'm going to go for the Microsoft and then /SignalR. And there you can see it's giving us that option. So we'll go for SignalR, and it actually shows us quite a lot of files in there, but I'm just going to keep this simple. So all I'm interested in is to go for this SignalR.js. Don't even need the minified version, though we would need that in a more practical application. We'll just go for that SignalR. And so there you can see that's included right down there. There we've got our SignalR. Okay, so now we've got that in there under the www root, which means it'll be served up as a static file to any browsers. Let's now put it in our browser code. So we saw we'd already got this game.js, and we can see that in the index view down there, we're getting hold of that game.js. But what I also need to do is get hold of that SignalR library that I just put in there. So what we're going to do here is we're going to do our /Microsoft /SignalR /dist /browser and then /SignalR.js. So that will make use of the library, and then all we've got to do is hook that up into our actual game.js. So the very first thing we're going to have to do, we're going to say let, and then we're going to have a connection, which is our connection back to the server. And so we're going to say equals new SignalR dot, and then we have this thing called a hub connection builder, and then we say dot with URL, and then in there we put our /GameHub. So remember, that's what we had in the program where we'd registered our hub, so that's what we're looking for up here. And then we finally just do a dot build on that, so that has made our connection back to the server. We then need to start that up, so we're going to say connection dot start, and then this uses a promise which we looked at ages ago when we were looking at JavaScript. So we have a then, and then in there we have an arrow function with no parameters, and all that's going to do is call this initialize. So I've already got an initialize method. You can see previously I was just calling it straight off. We don't want to do that now. We only want to call the initialize once the connection has been established that we're doing that start. Then you can see in the initialize at the moment I just set up the button clicks and that sort of thing, but the extra thing I've got to do now is actually put in all of those responses to the various methods we're sending out. So remember, we had things like our won, our drawn, our pending, our waiting for player, our game started. So we've got to now put in responses for those. So what I'm going to do is I say connection dot on and then the name of one of these. So let's go for that first one, waiting for player. So that's what's going to happen when waiting for player gets sent. And then what we do with that is second parameter in here is going to be, again, a lambda taking no parameters because waiting for player didn't send any additional parameters. So you've got to match these up by hand, but that's what we're doing. So that's no parameters in there. And then all I'm going to do there is call this method called switch to, which I've declared down here, and we're going to switch to a screen called RPS waiting. So RPS for rock, paper, scissors. And then that RPS waiting is simply this area here is now going to be displayed where it says waiting for another player to connect. So that's our waiting for player. Then we've got to go through all of those other ones. So we're going to have a connection dot on, and then we will have our game started. And game started, if we look back, actually I've just noticed I made a mistake because game started needs to take 3 parameters, the names of the 2 players plus the name of the group itself. And this is the sort of problem we have, that there's no strong typing on these methods, so we've got to manually effectively get these parameters matched up. So that would have hit a bug if we got that far, but I managed to spot that earlier. So we've got the name in there. So those are going to be the parameter to the arrow function. So P1, P2, and ID for the group name. And we're just going to forward those to the function we've already written called start game. P1, P2, ID. And again, we can see that we've already got that start game down here that just sets everything up, tells you who your opponent is, that sort of thing. Next one we're going to do, so another connection dot on, and this one is going to be for pending. So this is when we're waiting for the other user to make their move. Again, if we look at pending here, we can just see it takes the 1 parameter who we're waiting for. So we can just say waiting for arrow, and then we have a method again predefined called pending that just takes that. So there's our pending down there. So either we say your opponent has chosen, so they're waiting for you, or we're waiting for them. So that's what we've got on that one. And then just a couple more to do. We've got to have our connection dot on, and then if it's a draw. And again, if we just look back here, the drawn takes the explanation and the scores. So in here we put explanation scores. Those are the 2 parameters that are coming out. And then again, we've got the real hard work already done. So that just takes explanation and scores and basically just displays those on the screen. And then the very last one, connection dot on, and this was called won. And again, winner, explanation, and scores. So we're going to have winner, comma, explanation, and scores. And again, already predefined a method for that one that takes winner, explanation, and scores. And if we just scroll down to that, there we can see it just, again, prints out the results. So we've now hooked up the 5 messages that we can get from the server, from the Game Hub, and mapped them onto some JavaScript that we've written in advance. What we haven't done, though, yet is called any of the methods actually available on the Game Hub. So on the Game Hub, remember, we've got this register and we've got this throw, and so those we now have to call from our JavaScript, obviously through that connection. So that's what we need to do. So next thing we've got to do is in here, in our register function, so that's what happens when they click the button. And you can see we've just got hold of the my name, which we've popped into there. So that's the name they've entered. But then we've got to send this name to the server. So we do connection again, but in this case, we call a method called invoke. So we had on, which is setting up the function that will get called when a message comes from the Game Hub, but invoke is what we have to send to that. And then we're calling it register, because again, that's what was called there. And we can see it's expecting one parameter. So that's what we do. We send along the one parameter, which is just that my name that we've just set up. But then we've just got to do one other thing, which is worry about what might happen if that goes wrong. And so again, we're dealing with promises here. So I can do a catch on that. And in the event of a catch, what I'm going to do is just take whatever the error message was, and then we have a RPS-error div that we've got in there, and I'm going to set that .text on that, and then just pass in that error message. So that's done our register, and then remember our register, of course, is going to send back either the game started or the waiting for player, so it'll move things on through there. And then the other thing we've got to do, remember, as well as the register, we've got to have the throw, and so that's going to be down here in our throw hand. So I'm sure you can work out what's happening here now. We do a connection.invoke. It's called throw. And this one, as parameters, takes the group name, the player, and the selection. Well, at the moment, we don't actually have the group name. So let's just hook that one up as well. We nearly had it there. Remember, the game started is what sends us the group name as what we've called ID there. So let's just up here do a let group ID equals, and then just set that to blank to start with. But then on the start game, what we need to do is take that ID and say game ID equals ID. So that will now hook up that. And so that means in our throw, we can now pass in those parameters. So the group name, the player, and selection. So the group name is going to be game ID. The player is just going to be my name that we've already set up. And then the actual throw is going to be the selection that we've got coming in there. So that's sending those three parameters that we need. And then we again just need to put on there a catch. And in fact, it can be exactly the same as that one there. It's just popping out the error message. And so that really should be it. So in our hub, we had the endpoints, register, and throw, and we've invoked those at the appropriate time. And then we also had the various send asyncs, and we've hooked those up. And if that's all done correctly, we should see this now starts working. So let's run that up. So there we've got the Chrome. Again, let's bring up Edge and go to the same page. And then let's just hook that up side by side. And then let's enter Barney in that one. Click on enter. Seems to be working, waiting for another player to connect. In here, we'll put Betty, enter that, and then we can see we're waiting for Betty. Betty wins, rock, beats, scissors. So, quite a lot of complexity in the game logic there, but in fact the Signal R is relatively simple. Create a hub on your server side, derived from the hub base class. You have your incoming methods, in our case it was register and throw. You make sure you register your hub as part of your program, as part of the startup. And then also you can send async messages out, and the JavaScript has to register how it's going to respond to those and make the program run. So I hope you enjoyed that. As I say, although on the server side, using Signal R is pretty much what you're always going to do in a Microsoft environment. On the client side, in the browser, you could be using all sorts of different technologies. And so next time, we'll look at how you could have consumption of a .NET Signal R server, but consuming it in an Angular front end. So do look forward to that. If you enjoy that, do click like, do click subscribe, and I'll see you next time.